Well, now in video 6 we can relax a little bit and see what we can do with all that graphic stuff. I've written something called the plot files, and later when I do a review of everything I'll tell you how to download the plot files from GitHub, but for the moment we'll just have a look at the demos. The simplest of all of them is just called plot it. So you can do plot it and the name of a data file, or you can just do plot it. If you just do plot it, it'll look for a file called data.dat and read that one in. You obviously have to know how to format your data for the plot files, but that's all going to be in the documentation. Anyway, you can see we've got 3 curves in data1.dat. It's instructed them about what colors and what kind of lines to draw in the data file, but that's a case of following the documentation. The same thing goes for the axis labels and so on. The first thing to know about the plot files is that you've got a help page that's the same on every single one of them. All you have to do is press F1. There we are. Toggle help is F1. That's the only one you actually have to remember. So you can toggle the mouse, which means that in some of the programs the mouse actually controls your viewpoint, but of course you might want to suddenly go and use your mouse outside the graph, so you have to switch the mouse off in the plot file, and then you can go and click wherever you want. You can see there's lights and legend, boxes which you can alter the curve style and light position and so on. You can take a screenshot, reproduces a bitmap, or you can hit F12 to get PostScript output, which you can include in your documents. Again, all of these things really depend on which of the programs you're using, and the other thing is escape quits the program. So really the only 2 things you always have to remember is that F1 gets you the help page and escape gets you out of the program. Now let's see what we can do. I can move everything together up and down on the screen. I can zoom in and zoom out. So I use Control left and right moves the graph horizontally, and Control up and down moves the graph up and down. What do you mean by up and down and left and right, I hear you say? Well, there's 2 ways you can look at it. If you turn left, what you're actually doing is moving your viewpoint to the left, so the graph moves to the right. And if you press Control down, you move your viewpoint down, which means the graph looks as though it's going up. The other thing you can do is zoom in with the up arrow without the control and zoom out. Yes, once you've got everything the way you want it, you can press F12 or F11 to get a bitmap or a PostScript output for your graph. If I press F10, I can move the axis numbers about left and right and up and down, and I can move the y-axis label, for instance, with these arrow keys here, and I can move the left and right y-axis numbers and so on. So if you don't like the automatic way that it's placed the numbers in position or placed your axis labels in position, you can just quickly alter it using that without much effort. We're now in the plot files for Microsoft Windows in Plotit2, and let's have a look at what Plotit2 can do. Well, Plotit2 plots space curves. The mouse controls the orientation and rotation of the graph straight away, but if I do F2, I can now move the mouse about outside of the window and use it as normal, and then I can go back in and press F2 again and rotate that way. I can also go up and down arrow keys, and I can spin it around using the left and right arrow keys. And now you can see the advantages of all those lovely true type fonts using OGLFT, all being rotated without any loss of quality in 3 dimensions. We can use control up and down arrows to zoom in and out, and control left and right to shift your viewpoint left and right. Let's go back. So there we are, yearly loss per ton and daily quota in kilograms per year for lions and bears are these 2 3-dimensional space curves, as mathematicians love to call them, and they're really quite pretty, aren't they? If you don't want the legend, there's the F1, I think it says toggle legend somewhere, there we are, that's F4. So I can make that disappear or reappear. Oh, and if I do F2, I can move the legend to somewhere else. So that's pretty well what Plot-it2 does, and I'm sure you'll agree that it's very pretty. Another of the plot files is plot.cont, cont being for contours, and here is our contour plot of some data. Again, it's the default data file. We can move the legend about if we want. The units of the colors are going from 0.5 and under out here in blue to 5 in the middle of the circles. Is giraffes per season, daily quota in kilograms per year, and yearly loss per ton as joke units. So what it does is it reads in the 2-dimensional data, it colours them according to the range of the data, and it plots contours on the data. You can control the contours and everything in the data file. Again, we can move things up and down with the arrow keys and left and right, and if we do just the up and down arrow keys, we can zoom in and out. So we can move our legend box, we can get rid of it if we want, we can get everything on the screen to look the way we want it to using the arrow keys, and we can print it out using F11 or F12 depending on which you feel like. Now here's a nice little thing, it's called plot globe. Reads in a data file which gives you a world map, and you can spin it all around, you can change the lighting, you can make it rotate and left and right and so on, and you can zoom in as well. That's using the control up arrow. Well, it's getting rather blurry there, but you can see that we've actually got some outline data along with the actual color map. And yes, you can just put in all kinds of globe images that you want, read in the data, and again get everything the way you want it, and then print it out with F11 if you want to include it in a document. And then it's pretty, isn't it? Well, here we are in another of the plot files. This one is called plot mesh, but the actual executable program is called basic cube. So if I just do basic cube, you can see this come up. And what on earth are you looking at? Well, what you're looking at is a 3-dimensional tetrahedral mesh. If you're familiar with finite element methods for partial differential equations, you'll know what finite element meshes are, and here is a way of exploring and looking at the mesh that you've generated or you're other software has generated, and that's a really useful thing to do. So what can we do? We can use the left and right arrow keys to spin things around. You can see that the whole mesh is rotating up and down. We can use the arrow keys to zoom in and walk into the mesh and look around it, and we can use control left and right and up and down to move around in the mesh as well, and change our viewpoint. And of course the mouse is another thing. The mouse behaves differently whether you've got the left button held down or not. So if you hold down the left button, you can look at the mesh from different viewpoints, whereas you can move the whole mesh around by moving the mouse without clicking down on anything. So you've got very good mouse control, and you can explore your mesh this way. I'm going to extend this mesh plotting facility at some point, but for the moment it's not bad, and again, very good looking graphics. The PostScript output on F12 draws the lines a little bit thick, so they tend to sort of merge together into a black mess. So however, if you make sure that what you're looking at is not too densely packed, the output's really quite good. Let's do F11. Screenshot.bmp is there. Now we're in plot pol, and what that does is it plots polar data. I don't mean data from the North Pole, I mean what mathematicians like to call a polar plot, which is a bit like a contour map, or what we saw earlier on a square, but the variables are not x and y, left and right and so on, and up and down, but rotational. There's a distance from the center, r, and usually theta or phi if you want to call it that, or phi if you're Greek. No, I think it would be phi if you're Greek. So here we are, we can put in curves depending on the angle and the distance from the center. You can see this sort of rosy curve that it's plotted. It can read in two-dimensional polar data and gives you contours. You can see these contours here, that's actually are contours of the 2D data. The data, I think it's either sky radiances, or it could be a BRDF, or bidirectional reflectance distribution function. So that's certainly not in giraffes per season, but a very, very useful tool indeed. And that's how the plot files deals with data in r theta coordinates, either to generate curves or contour plots for two-dimensional data.